Okay, so example 2, right, is right here. Example 2 says, identify whether the function graph has an odd or even degree and a positive or negative leading coefficient. So guys, now we're just reversing it. They're giving us the graph here, okay? And we have to determine whether the graph has an odd or even degree and a positive or negative leading coefficient. So to determine that, all right, I need to first, we're reversing it. So if we come over here to my chart over here on the left, all right, I need to first determine as x approaches positive infinity, what happens to y, and as x approaches negative infinity, what happens to y. So when I look here, if I start just in the middle of this graph, right, as I go to the right, what happens overall? So as I approach positive infinity, what happens to my y? It what? Increases here. Even though we have all these dips at the end here, what happens? It's going to increase. So as x approaches positive infinity, p of x or y approaches positive infinity. See it? So when I go to the right here, my arrow is pointing straight up. So I'm approaching positive infinity. As x decreases now, I have to ask myself the second part of this. As x decreases or approaches negative infinity, what happens to y? It also decreases. My arrow is pointing down. So as x approaches negative infinity, p of x approaches negative infinity. And as x approaches positive infinity, p of x approaches positive infinity. So we need to come over here to see which one of these matches up. Don't forget that this one here should say positive, guys, okay? But again, we said as x approaches positive and negative infinity, I should have p of x. So I should have negative infinity and positive and positive. So when I look over here, I'm going to find positive infinity, and negative infinity. So it matches this end behavior here. See it? So therefore, what do I know about my polynomial? It has an odd degree with a positive leading coefficient, right? My leading coefficient is greater than 0. So you'd say it has an odd degree with a positive leading coefficient. And that's your answer. B here, all right, again, I'm going to identify the end behavior first to determine the degree in the leading coefficient as being odd, even, and positive or negative. So B here, right, as I go to the right, what happens as I approach positive infinity with x? So as x increases, what happens to y? It decreases or approaches negative infinity. So as x increases, see it? As x approaches positive infinity or increases, my y decreases or approaches negative infinity. When I go to the left, as x approaches negative infinity, if I go this way, what happens to y? It decreases. So now I'm going to find my chart over here that matches these. So again, I have negative infinity to negative infinity and positive to negative. So negative to negative is here, and then positive to negative is here. So I'm going to be looking in this bottom right square here. So therefore, because I'm in the bottom right square, my leading coefficient is what? Negative. It's less than 0. And I'm in the column of what? An even degree. So p of x is of even degree with a negative leading coefficient. So easy, you guys. We're just looking at the chart. All right, let's try 2a. So identify whether the function graph has an odd or even degree and a positive or negative leading coefficient. So if you start at 0, 0, if I go to the left here, as x decreases, right, as x decreases, what happens to y? My arrow is pointing up. It's going to increase. So as x approaches negative infinity, right, as x approaches negative infinity, y increases. So if I look over here, as x approaches negative infinity, y increases. So it could be one of these here, right? Nope, let's see. As x approaches negative infinity, y increases. So this one, or here, as x decreases, y increases. So I'm looking between these two here. Okay, so then, now I have to check as x increases, what happens to y. So now as x increases, y what? Decreases. So as x increases, y decreases. So that's this one here. See it? As x increases, y decreases or approaches negative infinity. So I'm in this block here. So that means what? My leading coefficient is negative. See it? And I have an odd degree, so you'd write odd, negative. Alright, let's try this one. Alright, as x decreases, so as I go to the left here, as x decreases or approaches negative infinity, what happens to my graph? It increases. Okay, so as x decreases, y increases. And then if I go to the right, as x increases, y increases. So I'm looking for positive, positive. So I have positive, negative, I have positive, negative, I have negative, negative, here's positive, positive here. Remember, this one here should be positive, guys. So as x increases, y increases. As x decreases, y increases. So therefore, I have an even degree, and my leading coefficient is positive. I think this is fun, alright? It's just categorizing. It's like solving a puzzle, you guys, okay? So I hope this video was helpful. Stay tuned for example 3 video on steps for graphing a polynomial function.